Welcome back Digital Switching System Virtual Class. In the last few classes we have discussed electromechanical switches like crossbar systems. Today, we will discuss the electronic switching. In electronic exchange, the life of the electronic device is independent of operation, but dependent on control parameters. Advances made in computer technology led to the development of the Stored Program Control (SPC). This enables the digital computer to be used as a central control processor and perform different functions with the same hardware by executing different programs. The electronic switching system evolved to overcome the major drawbacks of the electromechanical switching systems. Electronic exchanges have the more economic controls compared to electromechanical exchanges. The major drawbacks of the electromechanical exchanges are: 1. The non-flexibility of the design used. 2. Wear and tear of the control switches. Any data could be altered and could be controlled by the central processor. Even few functions can be controlled by the customers. Examples include: 1. Call barring. The customer can prevent unauthorized calls being made and can prevent incoming calls when they don't want to be attended. 2. Repeat last call. If a line is engaged, the caller can try again later without having to redial the full number. 3. Remainder calls. The exchange can be instructed to call customer at a pre-arranged time, for example wake-up call. 4. Call diversion. The exchange can be instructed to connect calls to different number when the customer goes away. 5. Three-way calls. The customer can instruct the exchange to connect a third party to a call that is already in progress. 6. Charge advice. This is indication call done by the exchange to the customer, to inform the call duration and charge.
In order to develop a complete electronic exchange, we replace electromechanical switches in the speech path by electronic common control. The figure shows a diode crosspoint relay. If A is positive, the diode is reverse biased and the crosspoint is open when A is negative. These electronic devices are used in the speech path. In order to implement a crosspoint, a 1-bit memory along with switching element is required. Cold, cathode gas tubes and PNP semiconductor devices are used to implement crosspoint because two functions are provided in these devices. But cost and implementation were high and complicated, which lead to the development of FDM and TDM system as a switch. An FDM system can be used as switch by bringing the two ends of its transmission path together. If the modems at one end of the path operate at fixed frequencies, but those at other end can operate at the frequency of any channel, then any trunk at one side of the switch can be connected to any trunk at the other side. On one side of the switch it must be possible to tune the filters to any channel and to supply any carrier frequency to any modem. This proved too expensive to put into practice. A TDM system can also be used as a switch. If any of the N receiving gates is operated by a train of pulses coincident with those applied to one of the N sending gates, then a transmission path is provided from the incoming trunk to outgoing trunk via a common highway. For a transmission system, fixed pulse timings are used. By altering the pulse timings, any incoming trunk is connected to any outgoing trunk, that is, N-X-N switch is obtained. Moreover, a memory which stores the appropriate pulse timings can be implemented relatively cheaply. Consequently, switching systems may be classified as 1. Space division, SD, systems. Each connection is made over a different path in space which exists for the duration of the connection. 2. Time division, TD, systems. Each connection is made over the same path in space, but at different instants in time. All electromechanical exchanges are, of course, SD systems. Both ST and TD electronic switching systems have been developed, but the latter now predominate.